This whole chapter is talking about solving quadratic equations. And we're going to look at a lot of different methods. And this is something that you've done before. When we look at a quadratic equation, we're going to have a lot of different methods, a lot of different ways that we can solve it. We're going to look at a couple of those methods today, and then we'll keep adding a few more methods as we go throughout the chapter. Like I said, we're only going to cover 3 sections here. 9.1 is the first one. And so 9.1 is pretty specific about the types of equations that we're going to see here. So typically when we have a quadratic equation is going to be in this format. Okay. And what makes it quadratic is that it has an x squared in it. Okay. And so any equation that has an x squared in it as its highest exponent will automatically be a quadratic equation. But not all of them are going to be written in this form. So today, the ones that we're going to see, for the most part, are going to be missing this b value. So we're going to basically take this b value out. And our equation is going to look more like this. And so we're going to talk about how to solve it. And the main method that we're going to solve with today is what we call the square root method. And it won't always be written like this. It's not always going to be set equal to 0. A lot of times it will be set equal to 0. Sometimes the 49 may already be on the other side. But our goal is to solve, right? Anytime we solve an equation, our goal is to find out what values of x make this true. And so as we solve this equation, just like we would any other equation, we're going to get x by itself. So I'm going to move the 49 to the other side, add 49 to both sides. And then to get x by itself, what are we going to have to do? Take the square root. So our answer is not quite. Positive or negative 7. So a lot of times when we do a quadratic, we're going to have 2 solutions, okay? Not always, okay? But a lot of times we will have 2 solutions, and so we want to put plus or minus 7 here. And the reason why is because when I square a negative, negative 7 times a negative 7 would be what, Shane?
Yes.
Negative 7 times negative 7 is a?
Positive.
Positive 49. So if I take negative 7 and plug it back in here, I get a positive 49, and 49 minus 49 is 0. Okay? So, and a lot of times we forget about that negative as being a part of our answer. So if we just wrote 7 today, we've only listed part of the answer. We've only listed one of the 2 answers. And so it's going to be really important to make a positive or negative on that. Okay, if I were to give you one like this, and a lot of these are going to be written in this form already, where the constant or the number by itself is already going to be on the other side. But we're just trying to solve for y here. And it's the same idea. We're going to take the square root here. And because both 4 and 25 are perfect squares, that's a really big thing of what we're going to talk about today is like, we got to recognize those perfect squares. We got 4, 9, 16, 25, 36, 49. Those are the perfect squares that we should become pretty familiar with because we're going to see those numbers over and over again today. So when we take the square root here, we get y equals plus or minus 2/5. The square root of 4 is 2. The square root of 25 is 5. And that would be our answer. Still put a plus or minus on our answer. Okay, the next one, if I gave you a decimal. Okay, what would be the best way to solve this?
Isn't it 12.12?
So if it was just 144, it would be 12. Yeah. But since it's 1.44, and what'd you say, Majan? What'd you think it was?
0.12.
Okay. So if I take 0.12 times 0.12, does it give me 1.44? You're on the right track. What's the square root of 1.44? $1.2, yeah. So here we would say plus or minus 1.2. Okay. And you can just put that in your calculator. If you don't know where your square root button's at, then you would put that in. Okay, so now we're going to talk about some different decimal, but it was a decimal that stopped. 1.2 is an exact decimal because it stops at 1.2. The answers today are going to ask you to write your answer possibilities. If I have x squared equals 45. Okay, we talked about knowing the list of perfect squares. The list of perfect squares are numbers that we should be able to recognize. 45 is not one of those numbers. And one way that sometimes we may write our answer is as a decimal. And if I take the square root of this, it would give me a decimal. And on the last one, it was as an exact answer, or leave it, and usually that's the way we leave it, as an exact answer. Well, if I take the square root of 45 in my calculator, it gives me this big long decimal that goes on forever. That's not an exact answer. It's a decimal that goes on forever, doesn't repeat, doesn't stop. And so we want a better way of writing it than as a decimal. The first thing we're going to do is the same thing we've done on the last couple. Okay, but we're not just going to leave it as the square root of 45 unless we can not simplify it. And it's been a while since we've talked about this. But if I'm going to simplify 45. Now, there's a couple of different ways that we can do this. It's been a while since we've done this. One way is to do the tree diagram, where we break it down into its prime factorization. So, for instance, find something that goes into 45. Probably the easiest thing would be 9 times 5. 5 does not break down its prime. 9 breaks down into 3 times 3. And so as I write this out, it could be 3 times 3 times 5. If I multiply these three things together, it gets me back to 45. But in order to simplify this, we're going to take out whatever we have a pair of. And in this case, we have a pair of 3s. So we're going to move that. And this would become 3 radical 5. Okay. So that would be one way that you could do this, okay, is do the tree diagram. I'm going to show you another one here, and just another way of doing it, okay? You guys kind of remember doing it this way with the tree diagram and doing the factor tree? That's one way you might have learned it. I'm going to show you another way, and I kind of like this way better. It kind of depends on the numbers that you have. But if I had n squared equals 40, once again, I take the square root of both sides. 40 is not a perfect square. So I want to break down the square root of 40. And this is kind of the way I prefer. You guys can kind of decide which way you like better. Okay, these are our first 10 perfect squares. I didn't include 1. 1 squared is 1, 2 squared is 4, 3 squared, 4 squared, 5 squared, 6 squared, all the way down to 10 squared. Okay, those are the ones, and you probably know some more other than that. 121, 144, maybe seen some of those and kind of remember some of those. Okay, 40 is not in that list. So what we're going to do is we're going to look for something from this list that goes into 40. And that tells me if I can simplify it. So in this case, 4 goes into 40. So I'm going to rewrite 40 as 4 times 10. And instead of doing the prime factorization, now we're just going to say, okay, since 4 is a perfect square, I'm going to take that out. The square root of 4 is 2. 10 can't be simplified anymore. None of these perfect squares go into 10. That's how I know 10 can't be simplified anymore. Okay? 4 doesn't go in there, 9 doesn't go in there. So that would be our simplified radical. And so we would say n equals plus or minus 2 radical 10. And that would be our answer. Okay? You could still do the prime factorization here. Okay, the prime factorization would be 2 times 2 times 10. So you'd have a pair of 2's, and you'd still get 2 radical 10. So it really just kind of depends on what makes more sense to you, as the pairs or just as a square root of what that number would be. What do you guys feel like you did it before? Like, did you do it something like this, or did you do the factor tree? The first one, you guys kind of feel more comfortable with? Okay, and that's fine. And that's kind of what I think a lot of people do teach it that way. I kind of teach it this way just because if you know your perfect squares, it makes it maybe slightly easier, but either way would be a way to get there. Okay, now something else we're going to talk about that we haven't talked about this year, but you've seen it before, is when I give you a problem like this. When we did it in Algebra 1, we got one answer. When we did it in Algebra 2, we got a different answer. Okay? We're going to do it the way we did it in Algebra 2. Because the way we did this in Algebra 1, if I were to take the square root of both sides here, what happens if I take the square root of negative 25? Try putting it in your calculator. You get an error, right? And so in Algebra 1, we would have said no real solution. Okay? There is nothing I can square to get back to negative 25. Well, in Algebra 2, we learned there is a new number, a different type of number. Anybody remember what that special number is? Imaginary. Yep. So, that imaginary number is I. I is the square root of negative 1. So whenever I see a negative under the radical, I know that we're going to use an I. Okay? I can't take the square root of a negative. So the way that I like to do this one, I'm going to take the square root of both sides. And I'm going to rewrite it as negative 1 times 25. But if I take the square root of negative 1 right here, that's going to become I. If I take the square root of 25, that's going to become 5. So my answer here would be plus or minus 5i. And that would be our answer. So i's will always come up if we ever have a negative under the radical. Okay, we haven't seen that since last year when we were in Algebra 2, and so it's been a little while. We haven't talked about them at all this year. Okay, some other problems that we're going to see today. We're going to still solve it. Okay, this is adding another step to it where we're going to have to do some addition or subtraction. We still don't have another variable here. We have an n squared, but there's no number or variable in this other than the n squared. And so still our goal is to get n by itself. So we have n squared equals 49. We take the square root of both sides and we get n equals plus or minus 7. Okay. So the only difference really there is we added a second operation to the mix. We got to do that before we do the square root. We don't want a square root right from the beginning. We want to get rid of the 7 first, move it over, and then do the square root. Okay, what if I gave you one like this? Divide by 25, right? So if it's plus or minus, we're going to do addition or subtraction. But this one's 25 times t squared. So we're going to divide by 25. Okay, and the good news here is that both 9 and 25 are in that list of perfect squares that we want, right? And so when I take the square root of these, square root of 9 and the square root of 25 would be plus or minus 3/5. Okay, so once again, we start recognizing those perfect squares, and we know that that would get us to a fraction. Okay, what would be my first step here? Divide by 4. Yep. And when I divide by 4, I get a negative 4. And right away, when I see that negative 4, what's that tell me is going to happen? It's going to be imaginary, okay? Because we're going to take the square root of both sides. If you want to, you can break it up as -1 times 4. I'll show you why in some cases that might be what we want to do, because we want to break this down. But in this case, the square root of -1 is I. The square root of 4 is 2. So this would be plus or minus 2i. Okay, here's a little bit different. We got a 5/6 in front of the x squared. The one we saw just a second ago was just a 4. That one's pretty easy. We divide by 4. So what would I do to get rid of the 5/6 there? Yeah, we're gonna multiply by its reciprocal. Okay, you could do it in 2 separate steps where I could like multiply by 6 and then divide by 5, but we can combine 2 steps into one here where I can really just multiply by the reciprocal. And that makes those 2 disappear. So anytime you have a fraction here, you could say I'm going to divide by a fraction, but then that's really a keep, change, flip problem, right? If I divide by a fraction like we've been talking about back from chapter 7, when I divide by a fraction, I'm really multiplying by its reciprocal. So that's really what I'm doing here. 24 times 6 gives me what? (24 times 6). (144). Okay. Okay, and then the good news here is, what's the square root of 144? 12. And the square root of 25 is 5. 12 over 5 does not reduce, so that is our answer. Okay, so kind of keep adding another step to it, right? This is really just a two-step equation with an x squared in it, okay? And when I do the two-step equation, we're gonna solve it just like I would any other two-step equation, and my first step would be to do what? Subtract 5. And we still got the 2 out in front, so we're gonna divide by 2. And we get x squared equals 8. Well, is 8 one of our perfect squares? No, okay. So we can't just take the square root of 8 and get a decimal, okay? We're going to have to simplify this. It's not a negative, so that's a good thing. So if I simplify the square root of 8, now's where you kind of do whatever you want to do. You can do your tree if the tree is what you want to do. Basically what we would get is we have 3 2's. So it would be 2 times 2 times 2. But remember, we're only looking for pairs. We're saying, what do I have pairs of? Okay, and I have 1 pair of 2's. So when we write our answer here, we would say plus or minus 2 radical 2. And that would be our answer. So there's a lot of different ways that we're going to write our answer that we really haven't been doing a lot of. Sometimes we're going to write our answer as a radical, not a decimal. Okay, your decimal is okay if it's a decimal that stops, like the one we saw early on today. Like 1.5 would be a decimal that's appropriate. But if it's a decimal that goes on forever and keeps going out in your calculator, we don't want to write that as an answer. Okay, there will be times where that will be appropriate, but for now, we're going to leave it as, we call this simplest radical form. If the square root of 8 does not come out to be a nice whole number, then we want to leave it as a radical, or in some cases, we'll have some i's with our answer today as well. Okay, a couple more here. 5y squared minus 7 equals negative 97. Step 1, what do you think? Add 7. Okay, next step. Divide by 5. Yeah. Okay, now a couple things going on here. And so this is a good one to talk about. Number one, we have a negative, so we know our answer is going to have an I in it. Okay. Secondly, 18 is not a perfect square. If this was like negative 25, then my answer would be plus or minus 5i, right? But 18 is not a perfect square. It's not one of those in our list. So what I like to do here is break down negative 1 times 18, because we're taking the square root of both sides. And this is kind of why I like to do the method that I was telling you about earlier. Find a perfect square that goes into 18. And you can do the factor tree. There's nothing wrong with the factor tree here. But what I like about this method here is we know that the square root of negative 1 makes I, and the square root of 9 makes 3. Both of those are coming out. So we get y equals plus or minus 3i, because those come out of the radical, and then we still have the 2 underneath. So this one, I told you you're going to leave your answer a lot of different ways today. This one has a radical and an I as part of your answer. Okay. Sometimes it's just a radical, sometimes it's just an I, sometimes it's a nice whole number and you just get plus or minus 6 or something like that. This one has a little bit more to it. Okay, the last couple here, this one's a little different, okay? And the reason why this one's different is we don't just have x squared all by itself. And we don't really want to FOIL this. To FOIL this, I'd have to take x plus 8 times x plus 8, and that would make this a little bit more difficult problem. And that's not even going to be something that we're going to talk about until later on in this chapter. So right now, our goal is to get x by itself. Because the plus 8 is on the inside of the parentheses, I can't subtract 8 right away, okay? It is connected to the square. It's on the inside of the square. So what would be the first thing that we would start with here? the square root first, okay? And that's where this gets a little bit weird, okay? We're going to take the square root of both sides, and when I write my answer here, this is still going to stay x plus 8, because when you take the square root of a square, it just gets rid of the square. But over here, you got to remember that we still have to write this as plus or minus 7. Hey, now this one we haven't seen yet today. We're going to write our answer a little bit differently here. And I think the best way to do this is to write out two separate equations. X plus 8 equals 7. X plus 8 equals negative 7. Okay, and the other thing that's going to be different about this is your answer is not going to be like plus or minus something. It's not going to be like plus or minus 5, like we've seen some. Here you're going to get two completely different answers for your two answers. We're still going to get two answers, but they're not going to be like the same number. So here we subtract 8, and I get negative 1. Over here, I subtract 8, and I get negative 15. One thing that I have not really talked about here is all of these are equations. And I probably should have talked about this more leading up to this, but the great thing about these problems today is that they're all equations, so they can always be checked. I can always take my number, I can plug it back in, and I can see if they work, especially on these two, just to show you that they work. If I plugged in negative 1, negative 1 plus 8 would be 7. 7 squared is 49, okay? You don't have to really show work, but then you at least know that it does work. If I plug in negative 15, negative 15 plus 8 would be negative 7. Negative 7 squared is 49. Both of them work. Okay? So in this case, they're both negative. You might get a situation where you have one positive and one negative. Maybe they're both positive. Just kind of depends on the numbers that you have and the problem. Okay, last one. I want you guys to try this one on your own. See if you can get it. 5n minus 3 squared equals 16. Okay, I'll do it while you guys do it, and we'll see if we get the right answer. Think you got it? What'd you get, Isaiah?
I got 7 over 5, I'll get negative 1 over 5.
Okay, feel pretty confident?
Yeah.
Everybody agree with Isaiah? Eli, you agree? Yeah? Shane?
Absolutely.
Yeah? Taylor? There it is. Okay, so we might get some answers that are fractions, okay? Fractions are okay. That one's just a little bit different than the last one, but still the same idea. Okay? That's all we're doing today. Just solving by the square root method and getting a little bit different answers. Maybe a few more problems than normal, but there's just a lot of different types. And a lot of these don't take a ton of time. You can kind of know from going through these that a lot of them are just taking the square root or doing a quick addition or subtraction before you take the square root.